this event. And yeah, so in last year, we have quite a few the seminar, and in this year, hopefully we will carry on about it. And my name is Kaida Xiao, so I'm an associate professor in the color and imaging in the School of Design, and I have been working for the facial skin colors since 2010. So today, I will introduce my study related to the facial appearance, measurement, perception, and preference. Okay, so in terms of when I study the skin color, it's many years ago. I read this report. This report is not a new report. It's a very old report that is published in 2005. And as you can see, some terminology is already not very correct if we look at now. But still, this indicate very, very important information. So they talk about for the human skin color, there are many different applications require the human skin color. For example, for the computer graphics, right? Think about that's a 2005. For the computer graphic, there's the rendering, the animation, the geometric modeling, they all require the skin colors. And in terms of the computer vision, we have the facial recognition, we have the people tracking, we have fingerprint identification, and for the medicine, right, they have the disease diagnosis, phototherapy, they have the drug development, and of course for cosmetic industry, they have a makeup development, cosmetic surgery, skin care. And what they mainly mentioned for all these applications, skin color is important. And the goal to improve those kind of application, one of the important factor is how we be able to truly measure skin appearance. So skin appearance, definitely if we be able to measure it accurately, we can improve all those kind of applications, okay? And think about it, that is 2005, right? And if we look at now, lots of those applications, it's dramatically developed. The face recognition, even the face tracking, even for our mobile phone, we can do that. You cannot believe it, right? And for cosmetic, of course, it's developed so fast. And but thinking about the skin appearance, right? It's been 20 years, right? There's still big challenge to truly measure the skin appearance in the big picture. It's still very difficult to truly measure the facial appearance, which including the skin, including the eye color, including the lips color. Okay, so it's since then it's really we try to work very hard to try to improve the technology for the skin appearance measurement. Okay, so that's something we're going to introduce a bit. The work has been conducted in Leeds. Okay. And in terms of the human skin color, as we know, because some of you, like you are really the world leading expert in the color measurement, right? And the color measurement, all the color imagery has been developed many years, has been very successfully applied for the all different industry, like the textile, paint industry. But considering the by using the measurement method, color imagery to human skin color directly, there are some challenge. For example, firstly, our human skin color is not a flat sample, right? Even for the facial appearance, it's a 3D shape, okay? And secondly, the skin color, it's a non-uniform color distribution. It's not uniform color, okay? And it's unstable, okay? So if you measure your skin color in the morning and you measure it again in the afternoon, you may surprisingly find how large the variation skin color about, okay? Because it's unstable. And comparing to the conventional color imagery, we do the measurement. We're supposed to measure a flat sample. We're supposed to measure a uniform sample. Of course, you know, we don't expect the color keep changing when you do the measurement. Okay, so that is a challenge for the human skin color measurement. And also, it's very interestingly, our human skin is really a complicated structure or complicated material. And the reason we say skin color like this, so they have a different layer, right? As shown in this picture, right? So we have the different thing could affect skin color. Most important factor would be three. It's a melanin, hemoglobin. And for the hemoglobin, that's including the oxygen hemoglobin and the deoxygen hemoglobin. Okay, so you can say it's affected by the two chromatophy, that is melanin and hemoglobin. More specifically, for the hemoglobin, we have the oxygen hemoglobin and the deoxygen hemoglobin. That is a completely different color. Okay, and this figure just indicate the different layer. For the melanin and hemoglobin actually is in the different layer of our skin, right? And as you can see, the hemoglobin is even deeper, okay? And the right figure, as you say, is observe the coefficients related to the melanin. The blue line represent the melanin. As you can see, the melanin figure is very, very smooth, okay? And you can say that deoxygen hemoglobin and oxygen hemoglobin, one is a red line, one is green line. As you can see, they are not smooth at all, right? And the figure go up from the 400 nanometer to 500 nanometer and going down and slightly up again. And very interestingly, you see there are some peak, right? This is the other figure, but in this figure, it's as you can see, it's a 1 minus absorbance. So that is more relevant to the inverse absorbance of the hemoglobin. It's more like the reflectance. As you can see, the red line represent oxygen hemoglobin, and the green line represent the deoxygen hemoglobin. Okay, as we just mentioned, if you see this red line about the 540 nanometer and 570 nanometer, they are two peaks. Okay, it's going down and up and down and up. And there's another peak for the deoxygen hemoglobin, is roughly speaking the 450 nanometer. Okay, and very, very interestingly, if you're comparing this three peak with the figure in the right bottom, that is a cone fundamental figure. Cone fundamental indicate how we perceive the color. And in our human eye, we have three cone, right? The reason we can see the color because these three cone, one is a red cone, one is green cone, one is blue cone, in very, very simple explanation. And if you're comparing the peak of this three cone and comparing this three peak with the peak of the hemoglobin, you will find they are very, very close. Okay, so this line indicate, roughly speaking, the peak of the blue cone. This line indicate the peak of the green cone. This line represents the peak of the red cone, okay? And so it's very interesting to see it. Then we talk it with the evolution psychology people, and they're also very interested in about it. Their explanation, that's my down to the evolution, because human being, as a human being, we had the need to look at people's face color so that we know whether they are happy or whether they are angry, whether they are cheating, okay? And because of this requirement, we down to the evolution, so we need to say the skin color more sensitive than other colors. To do that, our cone, the peak of the three cone is keep changing so that it can be matched to the skin colors, hemoglobin as much as possible, right? That's it's their explanation, okay? This just give us a very interesting hypothesis. So we perceive skin color more sensitive than we perceive any color else, okay? So now it's still, you can say it's a beautiful story. You can say it's a story hasn't been fully proved, but in terms of the color vision society, people try to test this hypothesis. But at least generally people believe that it's a true story. Okay. So in terms of for us, for as a color scientist, so we also very, very interested in that. And we go the different way. So we for the color vision scientist, what they try to do is try to really find the human perception about skin color. But we started the other way around. What we try to do is start from the color measurement, right? We want to develop some good methodology to do the skin color measurement. We want to collect some valid data for the human skin colors. And by this, we try to collect the skin color database in terms of the spectral reflectance. And if you are familiar with CIE color imagery, and people try to measure color using the CIE XYZ transtimular values. But from the skin color, we start with spectral reflectance. Why spectral reflectance? First, of course, it's represent the physical property, okay? It's nothing to do with your lighting because the lighting going to affect your color perception. What we're trying to do is really measure human skin color, which is independent of illumination. So secondly, we try to use we try to collect the ground truth data related to spectral reflectance so that from the spectral reflectance, we could predict the skin chromatography, which including the melanin and hemoglobin, right? There are lots of application, medical, especially medical application. They have a requirement to be able to predict the either melanin or hemoglobin, right? And even now, the technology is you are not be able to measure them directly. What you can do is you predict them based on the skin color. Okay, so if you will have the better understanding of the spectral reflectance, so we'll be able to do the better job in this kind of prediction. And of course, if we have a spectral reflectance, we'll be able to true simulate skin color and try to do the color reproduction. Okay, so from then about the 2010, we started to do the skin color measurement. We try to measure skin reflectance. We try to invite the people from the different ethical group. And we also try to investigate what when we use a different measurement methodology and when we measure skin color, how different the results we can get, okay? So in this case, we try to do the skin color measurement, use all possible measurement technology. That include what we call the contact method, that is spectral photometers, as you can see in this figure. So people hold a spectral photometer, then you contact people's skin, and basically you got the built-in lighting go to your skin and reflect it back to this instrument, and the instrument gonna be record spectral reflectance directly, okay, in each different wavelength. And the other method, we call it non-contact method, that is using the telespectral radiometer. And in this, the figure in the right bottom figure, the right one, this is telespectral radiometer. And you also can use a digital camera, okay? But to do the non-contact method for the skin color measurement, you need to have a built-in lighting, okay? So in other words, you need to have a lighting to provide very smooth and uniform lighting to people's face. And then you use either camera or the telespectral radiometer to measure their skin colors. And for the telespectral radiometer, you measure spectral power distribution, and you can calculate skin reflectance. For digital camera, you capture the camera RGB. You can predict skin spectral reflectance. Okay. So, and we also we talk about contact method and non-contact method. Also, if you consider whether you measure the spot measurement or the imaging measurement, that's another kind of the definition of skin color measurement method. What is spot measurement? If you use spectral photometer to do a measurement, what you can do? Basically, you can measure some important point. For example, you can measure forehead, you can measure cheekbone, you can measure chin, right? So if you either use spectral photometer or you use spectral radiometer, you can only measure limited point because you are not able to measure too many points in the human face, right? In this case, you measure the 4 point. After measurement, what you get? You basically get the full color information for this full color only, right? Either you get the XYZ transstimular values, or you get the skin reflectance data, but that's only for very limited number of the color point. That's the reason we call it spot measurement. Okay. How about for the imaging measurement? So generally, what you try to do is you use a digital camera to capture the whole face. And you get the whole image. And what you do is in each pixel of your color, you can predict their either say XYZ transstimular values or the spectral reflectance. Okay, so in this sense, for the imaging measurement method, you get much more informative data because you are not only get the 4 point, you can measure any point in your face. And after measurement, you can still load your image and you do the different color measurement. Okay. So definitely there are advantage to use the imaging measurement method. In other words, to use a digital camera to do the facial imaging, facial color measurement. Okay, so in terms of the work we conducted, it's to collect the skin color database. We try to investigate there are two aims. First is we try to investigate uncertainty in skin color measurement. So in other words, what kind of instrument you should be used to do your skin color measurement, and what kind of parameter you should be used. Okay, so then we try to recommend a protocol for good measurement for the skin color. And secondly, we try to collect some useful skin color database. At the moment, they have too many skin color database. None of them are very comprehensive. And the problem is they are not be able to combine each other because every database using different measurement instrument or measurement method. Okay, so in 2013, we established a technical committee in the CIE, and we work together with different people in the different country, and hopefully we can collect some useful data. Okay, in terms of skin color measurement uncertainty, we try to measure skin color using different measurement parameters, and we comparing spectral photometer results with the spectral radiometer results. Okay, even for the spectral photometer, as you can see, you can measure in the different size of you can choose a very small size, a small hole, or the relatively large size. And even you can use a different pressure when you do the skin color measurement. And in terms of the telespectral radiometer, if you use a different distance, that also indicate the different size of measurement for your skin color. As we mentioned, because skin color is non-uniform, so size is really matter, right? If it's completely uniform, whether it's a small size or large size shouldn't give you the different results, okay? And what we're trying to do is we try to measure the repeatability. What that means, if you measure skin colors and you repeat your measurement in different times, and you calculate the color difference between the different time of measurement, that's what we call repeatability. And we try to investigate repeatability for the skin color. And as you can see, in this table, in the mean results in this line, the repeatability for skin color measurement, roughly speaking, it's about 0.3, 0.4 color difference unit for the spectral photometer. It's 0.5 color difference unit for the telespectral radiometer measurement. What does it mean? You measure your skin color first time and you measure the second time. Roughly speaking, you have 0.5 color difference between these two times, okay? And whether 0.5 is large or not, okay? Then we comparing measurement of skin color using Pantone skin tone guide. That's its skin color chart. If you measure skin color chart in the different time, repeatability is a 0.07. So if you measure real people's skin, the repeatability is 0.5. If you measure the skin color chart, repeatability is 0.07. As you can see, it's much, much larger, okay? But whether it's large or small, difficult to say. At least we know if you measure human skin color, your repeatability results, roughly speaking, 0.5 delta E, okay? And we also try to measure the instrument agreement. What does it mean? If you measure your skin color, your spectral photometer, and you also measure the same skin color using a telespectral radiometer, we try to investigate how different your results for the same skin color using different instrument, okay? And in the very roughly speaking, for the TSR, if you measure use different position indicating different size of measurement, you can get about 2.8 color difference unit. Okay, if you measure using spectral photometer using different parameters, and the results and as large as a 3 delta E if you use a high pressure with a different size. Okay, if you're comparing the telespectral radiometer measurement to the spectral photometer measurement, the result is even larger, right? And but if you're comparing the Pantone skin chart, you can say that the instrument agreement is very good. Okay, so again, it's not good or bad measurement. We just try to set up a threshold. If you measure skin color using current the measurement method, that's the result you would be expected. Okay, that's a research we has been working for the skin color measurement uncertainty test. And then we also start to collect skin colors. And we, in our lab, we try to use all different methodology. As we mentioned, we have a telespectral radiometer, we have a spectral photometer. That's conventional way to do the skin color measurement. We also have the digital camera with this viewing cabinet so that we can capture human's face, we predict their skin color. We also have a 3D camera, right? That is 3D MD camera so that we can capture whole face, not in 360 degree. So because we are three-port system, we can capture the face at least 180 degree, which is good enough, right, for the human face. And at the moment, we've been working on the skin color data collection. We has been conducted our measurement in the different country and for the different nationality or ethnic groups. Okay, so that includes the Chinese, Caucasian, Kurdish, South Asian. Thanks for Sutitra and Pakistan data. We're collecting in the different time in Spain and in UK we collect the Africa black as well, right? And that is the data that has been collected, all the data in terms of spectral reflectance. Okay. And the next example, it's our early paper to indicate the difference about the skin color distribution in different ethnic groups. As you can see, the Caucasian data in the CIE-LAB color space, and the top figure is redness A star against the yellowness B star, and in the bottom figure indicate the chroma, was the lightness. Okay, and all each individual data represent one skin color measurement for one subject. As you can see, for the Caucasian, they have a large variations. And for the Chinese, very interestingly, you can say they have a really small, we call it color gamut, somebody call it the color envelope, and in general, it's just skin color distribution, okay? And this is the results for Kurdish and for the Thai. And if you plot this figure to cover the largest area, as you can also say it, we calculate the area. And for the Caucasian, as you can say, they cover a large area, but smallest is a Chinese, that is a red line, as you can see here, okay? So that is indicate the skin color gamma boundary. So for the different ethnic group, you have a different skin color gamma boundary. But it's also interestingly, as you can see, all these colors, if you look at their hue range, it's always between 0 degree to the 90 degree, okay? So in other words, it's roughly speaking, possibly the minimum hue angle will be at least 10 degree. And what is indicated, if somebody tell me they do the measurement, they found their skin color is blue, definitely we never see this situation, okay? And it's indicated, at least from our database, all the skin color is kind of the reddish because the hue angle between about 10 degree to the 90 degree. You can see your skin color from the red to the yellow. It's never go to other color region. For example, the blue, right, the green, and yellow to green, right? Okay, that is the skin color gamma boundary. And from those data set, we also further investigate, we do the skin color cluster analysis. So you can say that is cluster we divided for the different ranging of the skin colors, okay? And you can do the using the different cluster analysis, and that is all skin color data we collected, and it's kind of a beautiful banana shape, okay? And you can further do the skin color cluster and to divide it to the different regions. And the other work we has been working, because all the data we collected as spectral reflectance curve. Okay, and so we further investigate from the spectral reflectance curve. Then we found this is the spectral reflectance curve of all Caucasian skin. The middle figure is a reflectance curve of Chinese skin, and the right figure is a reflectance curve of Kurdish skin. Okay, as you can see, if you take the average, surprisingly, yeah, looks very, very similar. That means the skin color, they have a largely overlapping, even consider different ethnic group. Okay, and we try to comparing the average results of the skin color across different ethnic group. Surprisingly, if you look at this, it's a cheek color. If you're comparing Caucasian average skin reflectance with Chinese average reflectance, it's almost overlap each other. Okay, that is for the cheek area. But if you look at the forehead, what you can see, the Caucasian spectral reflectance curve is just above the Chinese average reflectance curve. But the shape of the curve looks very, very similar. Okay, I think that's to do with the melanin. As you know, the melanin is very smooth. So in the forehead, comparing with Caucasian and the Chinese, the difference might be due to the melanin part. And also for the neck, you found the similar tendency. Okay, so generally from those spectral reflectance, we can investigate more. And we also do the principal analysis and principal component analysis. And we found for the skin color, even we just use 3 principal component that can represent very well for the whole skin color spectrum. For example, we only use 3 principal component, we can represent pretty much 97% of the whole skin spectral reflectance. Okay, and from there, because we talk about spot measurement and also the image measurement, we're really trying to develop the better technology to using the image measurement technology. And in this case, for the image measurement, what you really to do is use a camera to capture your whole face. As you can see in the right figure, there are different kind of the camera. They have a very simple method. They have a slightly sophisticated method. They even have a more sophisticated method, and even you can have a 3D camera, right? But in general, what you captured from your human face, if you use a digital camera, what you captured, it's a camera RGB, okay? And what we're trying to do is try to predict from camera RGB to the spectral reflectance, okay? In this case, how we can improve our model for the skin spectral reflectance estimation, that is a key technology we try to develop. And in very simple way. So to do that, to do the spectral reflectance estimation, generally, there are 2 steps. The first step is to your camera, okay? So either you do the camera color characterization, or you do the camera spectral characterization. So you try to predict camera RGB either to CIE XYZ transtimular values from the digital signal to a human eye response, or you predict your camera RGB to the spectral to predict the camera spectral sensitivity function. Okay, that's what we call the camera spectral characterization. Okay, that's a step 1. The step 2 is really to do your human skin color. That's a human skin to do with human skin reflectance reconstruction. Either you do XYZ to spectral reflectance, or you do the RGB to spectral reflectance. In condition, you have to know the camera spectral sensitivity from the step 1. Okay. So generally, there are 2-step process, and each step can generate an error. and it's an unpredicted error. And when they map together, they will generate another, the uncontrolled error. So in order to do the better process, it has been working, try to connect the two-step process to the one-step process. Okay, so because we have a spectral reflectance data for the human skin color, we do the principal component analysis. As we said, 3 principal component has been give lots of information. So we do the PCA and we get some the eigenvalue, then we directly build a connection between camera RGB to the eigenvalue, so that in simple word, we connect the two-step process to the one-step process. And in the right figure indicate the performance by using the two-step process and the one-step process. And we found the two peak value, which we believe is very, very important for skin colors. It's always lost when you use a two-step process. But when we use a one-step process, the algorithm, the two peak is well preserved and overall performance also much better. Okay. And so we developed the skin spectral reflectance estimation method, and we collecting some skin color database. And this is an indication of the 40 Chinese, 40 Caucasians. Okay. And for each the facial image, we be able to predict their spectral reflectance. And what does it mean? So your facial image can be truly represented in a display, can be truly measured using get the spectral reflectance data, or say XYZ transtimular values under different lightings. Okay, what we call it is Liverpool's skin color database. And in the recent couple of years, we're also collecting a large database in University of Leeds. So we have a much larger the facial image database, and we also have their spectral reflectance data. Okay, and let's see. So that is what we have been working for the skin color measurement. So generally, as a very quick summary, we develop a new method to be able to do the imaging measurement for the skin color of the facial appearance. So we use a digital camera to capture the human face, and we use algorithm to predict spectral reflectance for each pixel of the facial image. Okay, and we by that means we're collecting a useful or the ground truth facial image database. That's something we've been developed for the skin color measurement. Let's talk a little bit the skin perception. So if you think about it, you have a good technology for the skin color measurement. Whether those measurement data can truly represent facial appearance about the human perceived facial appearance, I think it would be difficult. Even you can say my measurement technology is really advanced. I can measure each pixel of skin color accurate, which has never been done before. But with those information, whether it's good enough for the to predict or to represent how we perceive facial image or how we perceive facial appearance. Think it's very difficult. That's it indicate the measurement. But in terms of the human perception, we are not only we look at the whole face in one go, right? We don't look at each pixel. But if we look the whole face, that would be something to do with skin color discrimination. We have a color difference formula, but that color difference formula, whether it's good enough for the skin color difference prediction, and we also have the color appearance model, whether those color appearance model is good enough to predict the overall facial appearance. That's something we also very interested, has been spent time to work on that. And we has been the first study has been work is a skin color discrimination. So when you look at the human face, you actually look at human face is not uniform and it's textured, right? And in this case, we try to do the just noticeable color difference for the skin texture. As you can see, we do some experiment, we show people the full color patch as all the human skin colors with a texture. And we ask people to select which color patch is different to other three colors. Okay. If they found it easily, you found it correctly, we reduce the threshold, we reduce the difference between them until we found just noticeable color difference. And we do it in the all different direction. I think we do the 14 directions, and eventually we can plot the ellipse that indicate just noticeable color difference for the skin color. And this result for Caucasian is a result for the Chinese skin. And as you can see, all those ellipses, we do it in the different lighting condition, either in the dark room or in the daylight condition or in the cool white fluorescent. As you can see, it's ellipse always. If you look at the skin color, it's all in the daylight lossy. Okay, and they also indicate they have the different threshold. Okay, and as you can see, they have the big picture, and they have the threshold, they have a small threshold under the different lighting. In the cool white fluorescent, you have a much larger the just noticeable threshold comparing with daylight or the D65 lighting. That's really to do your adaptation, in other words, memory color. Okay. Another work that has been working is a facial appearance. So basically, what you look at human face is whole face. If you think about, you look at the whole face and you want to one color to represent the overall the facial skin color. Can you do that? If you can do that, what would be the most representative color? Okay. You can think about it. I take the average. I using the whole facial image. I using whole skin color. I take an average. That would be the most representative color for the whole face. But whether it's true or not, we try to design an experiment to testing for that. Okay, we have a whole face in the left, and we want people to change their lightness, the redness and the yellowness in the right figure. That is a uniform patch. Okay, so basically people can changing the colors in the right figure until you match this color to the facial image. If it's matched, that means this color is most representative. Then we investigate what's this color, whether this same as the average color of the skin color. Okay, and eventually we found that it's not the most representative the facial color. It's not equal to the average skin color. Actually, as you can see, the match color is much lighter than the average skin color. But in terms of A star, B star, it's more close. But for the lightness, it's just in the top. Okay. And the other study, we also try to investigate what is whiteness, redness, and yellowness. So people now using LAB to indicate skin colors, but in other term, people like to use the whiteness, redness, or yellowness. But the problem is there is no good model to predict the skin to facial whiteness, redness, yellowness. We try to develop a model to do the prediction for that. Okay, so we do the experiment. We want people to scale their whiteness, redness, yellowness for different facial image, so that we'll be able to predict the whiteness, yellowness, and redness from LAB values. And we found those three appearances can be predicted very well. And so you can say I don't spend too much time on that, but we develop a better model to be able to predict the whiteness, redness, and yellowness from LAB values. Okay, that's the work that has been done for the skin color appearance scaling. And finally, I give a very quick introduction about our study on the facial preference. Okay, so facial preference, of course, that would be indicate your facial attractiveness or the facial healthiness or the visual age. That's all something we talk about. It's about the facial preference. Okay, what we're trying to do, we try to investigate whether the human skin color gonna be affect your facial preference. Okay, the human skin color that would be include the average skin colors as example of this, or the local skin color, for example, your cheek color, your eye color, your other the skin color, the forehead color, for example. Okay, they also include the skin color variation. Okay, for example, the part of your cheek color, whether your skin color is very smooth or not. And also we indicate the facial color contrast. What does that mean? That means your lip color with surrounding skin, your eye color with surrounding skin, your eyeball color with surrounding skin. All these kind of things, what we call is facial color characteristics. Okay, and for the same facial image, we do psychophysical experiment. We try to assess their facial attractiveness, healthiness, and visual age. Okay, and we use the 40 Chinese image, 40 Caucasian image. What we do is we calculate all possible the color measurement. That's include average skin color, color variation, color contrast, for example. We do the psychophysical experiment. We want people to look at the whole face. Then we want them to scale it. What is to scale their facial attractiveness from the least to the most attractive. We want them to scale the facial healthiness, and we want them to scale the visual age. You just give an age based on the facial image you has been seen. Okay. As you can expect, the facial preference could be culture dependency, so that we do want to the Chinese people to look at the Chinese facial image. We also want to the interested in the cross culture that indicate that when the Chinese look at Caucasian facial image, comparing with the Chinese look at the Chinese facial image. Also, when a Caucasian look at Caucasian image, comparing with the Chinese look at Caucasian image. Okay. So eventually we do find they are really culture dependency. Okay. And for example, for the Caucasian, we try to investigate the relationship between each facial color characteristic with the facial preference. We calculate the relationship, and we found for the Caucasian, what is the most important factor? It's the color variation for the cheek. And other things is not the hugely affecting the results. And for the Chinese, what is the most important factor? It's the color contrast, the lightness. Okay, so basically we found there are the culture dependency. For example, for the Caucasian, you have the color variation is the most important. And for the color contrast for the mouth, it's not important. And for a Chinese, mostly important is color contrast. And the L star and A star, that's the average skin color. As you know, the Chinese expecting the lighter color or the whiter skin color, people will prefer. They also prefer it's your color has a less redness, okay? But in Caucasian, you don't have this kind of results. And in terms of the visual age, it's also very interesting. And for the Caucasian, mostly important, it's also the skin color variation. Okay, if you have the large skin color variation, or your skin doesn't look very smooth, then people feel, oh, that's it indicate you have a large age range. But for the Chinese, most important still the contrast. Okay, and also the L star and B star. So in a simple word, they are really cultural dependency for the skin color preference. Also, there are good relationship and between the skin color and facial preference, but it's highly cultural dependency. Okay, and what we're trying to do is whether we be able to, from the color appearance, whether we be able to predict their facial preference. Okay, if you consider each individual factors, for example, average skin color, color variation, and color contrast, that can indicate between 10% to 30% for the average skin color, 11 to 20 about color variation, 10 to 50 about color contrast. So we develop a model, try to map all these factors together so that we can predict between 20 to the 56 as a facial color predictors, which directly affecting your facial color preference, the attractiveness, healthiness, and yeah, the visual age. Okay, and I think that's it for our study. So generally, we have been working on the facial color measurement, and that is one way to do that. We're collecting a skin color or the facial image database, and that's first work we has been working. And secondly, we start to work on the color perception, skin color perception. That include the color difference, including the facial color appearance, because what we really look at, not a single color in your face. We look at is overall your facial image, which gonna be affecting our color perception. And finally, we start working on the facial preference. So we try to find the relationship between the skin color and the facial preference. We do find they are really strong correlation, but it's highly cultural dependency. Okay, think that's it for my talk. Anybody got any question? Hello, Kevin.
Hi, Kaida. Thanks for that. There's two question areas I'm quite interested in. The first one really is about one of the variables when you're measuring color phase. So if I take the example of myself, my color and my face is dependent on, I think, two major things: the time of the year, which is partly to do with how much sun I've been exposed to and that, so I can go lighter and darker and things like that. And then the other is how hot I am, or how much exercise I've had, or how much alcohol. So there's dilation of capillaries and I become redder. So in terms of the experiments, were you trying to take into account those variables in any way? Because my color varies an awful lot because of those factors. So it's not just variable between people, but for a given person, there's a lot of things that would vary in terms of the color of the face. So that's the first question area. But I'll give other people a chance, but there's another area on the preferences, which I might come back to if we've got time. Thanks.
Yeah, it's a very, very interesting question. Thanks, Kevin. So in what we're trying to do is we develop a measurement technology so that we be able to measure those difference. Okay. And we try, actually, I didn't mention it in this study, but we do the two study. First study, we try to measure the people's skin color under sunshine. Okay. So if you do the for example, you measure it before summer and after summer, right? We collect the data in span because they have a good sunshine there. And then we comparing their color difference. Then we found using our skin color measurement technology, we can easily distinguish this difference. Okay. And the second study we has been working is exercise. We want people to do a 100-meter run, and we measure it before and after. We also found from our measurement technology, we can easily distinguish this difference. That means the measurement technology is valid or the robust, and we be able to quantify those differences. But of course, as you mentioned, the skin color is variable, right? So we be able to measure it, those variable, and hopefully we can predict this variable in some sense. Okay. You are muted, Kevin.
Yeah, and I realised. Have you done those sorts of studies where you've taken certain individuals then and just
Yes.
done lots of measurements with exercise, with sun, and
Yeah.
you know, almost like a longitudinal study? And they say the skin thins out as you get older and stuff like that. So there's all sorts of factors that actually are variables within a given person, and it'd be quite interesting. But I guess it depends what you're trying to achieve in terms of you're trying to have the methods and ways of doing it. But actually, as you've already said, it's very complex, isn't it, in terms of someone's individual color, and it changes within a day or even minutes. It can sort of change.
Yeah.
So
Yeah,
okay.
some study even mentioned if you eat good food, they're gonna be change your skin color, right? We haven't tried it, but maybe that's possible, right?
Okay, thanks.
Okay, so anybody got any questions? It's your again, Kevin.
I'll wait. I said I'd give someone else an opportunity, but
Okay.
because my other question there is to do with the sort of the preferences you were talking about towards the end. But I don't know if anyone had any questions about the other area first.
Hey Hua, do you want to ask a question first?
Yeah, I would like to ask a question about the imaging measurement, because you mentioned about using the imaging measurement for the skin color collections. So as you mentioned that you might calculate the skin color of each pixel. So in the end, there will be a conclusion about what the average value of each pixel's the RGB value of each pixel, or there's any consumption that we could get when we got the imaging measurement for the skin color.
So thanks for the question. So for the image method, the advantage of the image method is you in one go, you get all the information for the different pixel. So basically for each pixel, you can get their RGB values, and you also can predict their XYZ transtimular values, right, using the right algorithm. That is the advantage of the image method. But it doesn't mean you use the image measurement method, you can get your facial appearance correctly, because what you look at is not only individual pixel, you have the overall the impression. That's the reason we also start working on the facial appearance. So be able to predict or be able to find the way to find the most representative color for the whole face rather than the individual pixels.
Okay, I see. Thank you. And another, I'm just curious whether the distance between your face and the camera would affect the result we got when you're using the camera to test the skin color.
Yeah, can you say it again, because it was a little bit noisy before? Yeah.
Yeah. Whether the distance between the face and the camera will affect the result we got.
Yes. Yeah, definitely. Okay. As we also mentioned, even when we use spectral radiometer, which is in the big sense is similar as camera, the distance really affecting the result, because the distance that indicate the field size you measured for your skin. Yeah.
But there's any standard or that we could use for or we just keep the same distance every time we do the measurement?
Yeah, so you need to keep the measurement distance same, but whether they are standard, there's no standard. But we try the different distance. We try to find which distance in the optimized results.
Okay, thank you. I got it. Thank you.
Thank you.
I think perhaps, Kaida, we ought to make the point that what you've tried to do here is firstly define what the variables are, and secondly to gather data that seek to provide measurements that contribute to some of these variables. And I think as you look back, you'll find that you've been influenced by the potential application of the data measurement.
Yeah.
Whether it's medical or cosmetic. I mean, the bottom line is who's paying the money to do the work.
Yeah.
I think Kelvin's question about the change in skin color by time, be it over a day or over a month or a week or a year, is a very interesting one.
Yeah.
And it would be kind of fun to do. The difficulty is we would have to find an application. I quite understand in the cosmetics world, there could be a very useful application, because it's no use ladies putting on a lot of makeup if it's going to be affected by the time of day. And so one's acceptance, one's attractiveness, one's preference, etc., all going to be influenced by that. But on the other hand, we have a pretty good model as to what the skin reflectance looks like. And so with the suitable data, it should be possible to model these things. Now, I know you and I have got a sort of love-hate relationship with models. We don't particularly like them. But this might be an example where a model could be very useful, because we could make decisions and then based on data and then perturb the data in the model to find out how it would change the preference, attractiveness, etc. So I think that was an excellent summary of what I know is a lot of work. And I think we've made big steps forward, but there's a long way we could go. Well done, Kaida.
Thank you very much, Mike. Absolutely. I think we've been working on this, then we has I cannot say it's an absolutely better technology, but we have a different technology to measure skin color comparing with the conventional method, right? And then we need to further employ how we're going to use this technology for the different applications. We are still in the early stage to do that.
Absolutely.
Yeah.
If I may just come in on that and applications.
Yeah.
Surely cosmetic, there are markets, like if you think about it, you know, selling, people go into maybe a shop and get skin matches and get advised on cosmetics and what color suits them. But what if they've been to the gym? So you might want to wear different makeup or different things after you've been to the gym, or in the summer, in the winter, or different seasons. So you could, I would have thought the cosmetic companies would support all these sort of applications in the variables of people, because they can actually, rather than just selling a few different cosmetics to them, you're actually going to be selling loads of different ones after they've been in the sun or not been in the sun or been to the gym or done it. And you're actually, you know, it might, I'm not necessarily supportive of it, but I could see how the cosmetics industry could actually start trying to even sell more and more cosmetics for all sorts of different reasons and applications. So, but if I may, go to the second area of questioning about this preferences. I find it really interesting that, and I might not have caught all the things that you've done, and I know you had limited time to talk about that, but there's all sorts of things I think that influence in the preferences, and people talk about the shape of a face and even the shape of a nose and the distance between the nose and the mouth, thickness of lips, all these sorts of things. So it's partly about how do you control for all those variables. So again, would it be a case you might have my face, but then you would change the color of my face and ask people to rate that variable, rather than compare the attractiveness of my face to say your face or somebody else's face. So it's just, can you, within the model or whatever you're doing, just change the variables of a set person's face to try and make it more attractive, rather than comparing different people's face of different colors? Is because I wasn't quite sure how it was operating in practice, what you were doing.
It's also very interesting. So you talk about the facial feature, right? So definitely your facial feature going to affect your facial preference. Even for ourselves, we don't expect from skin color you can predict the facial preference completely. For example, in other words, whether you change the skin color can make you really much preference than other people with a different feature. I don't say that's easily to be compared, but what we really trying to do is for the same feature, right? If you change your skin color, would that affecting the facial preference? Yes. And would that culture dependency, that means generally Chinese, they have some tendency, Caucasian might have some tendency. Of course, individual would be different to the average results. But if you consider the average results, would that be strong tendency? We found possibly. So yeah, so it's also needed to thinking about to the applications, right? Like Kevin mentioned, feature gonna be affected, and also color gonna be affected. Whether it's easy combination, both of them, and how it gonna be affected for the different applications. Definitely, we need to think about more about it.
Okay, thanks.
Okay, thank you. And if there's no more question, thanks for all your coming. And thanks again for very valid support. As Chelsea is here. Okay. Thank you.
Thank you so much, Kaida.
Thank you. Bye bye.
Bye.
Thank you.
Bye.
Bye.